Hi everybody, welcome to physics. So yesterday I know I assigned a lot of questions, so if you didn't get a chance to complete all of those, I'd love if you could go back and do a couple more of those questions, just so you have a good foundation for our circuit work today and so on. Okay, so from 1800 to 1876, scientists believe that positive charges moved in batteries. So in 1876, an experiment at Harvard showed that negative charges moved in conductors. Around 1897, J.J. Thomson discovered the electron, and physicists then understood that electrons, the negative charges, flow, not positive charges. So the term current, which we talked about yesterday, so I, means the flow of positive charges from an anode, which is the positive end, to the cathode, the negative end in a circuit. So that is also known as conventional current. Okay? So then the opposite of that, the flow of negative charges from cathode to anode, is called electron flow. So if you look at this diagram here of a circuit, we start at the battery. Let's look for current. So current, it's going to be the positive charges are going to come out of the anode, so out of the positive end, and they're going to flow. So follow the red arrow. They're going to flow into the cathode end, into the negative end. That's known as conventional current. Okay, so then the opposite, the electron flow, is going to start at the negative end, the cathode, and it's going to go into, so the blue, it's going to go into the anode. Okay? So then we have Millikan's oil drop experiment. And if you're looking for more information on this, there will be a short video posted in the classroom. But Millikan proved in 1917 that the static charge on an object was always a multiple of a tiny electric charge. So it was always the same little number, and that is the electron. So now we know that the elementary charge, he called it the elementary charge, and it is 1.60 times 10 to the negative 19 coulombs. So that's a lowercase e. Okay, and that value changes if it's an electron or proton based on, pretty obviously, if it's an electron, it's going to be negative. And if it's a proton, it's going to be positive. Okay, so we use this elementary charge when we're trying to figure out the amount of charge, so Q. So we learned about Q yesterday and used it in some of those problems. So Q, the amount or quantity, which is measured in coulombs, equals N, so the number, the number of elementary charges, so how many of them, times E. So that's elementary charge, which is going to be one of these numbers, depending if it's electrons or protons. Okay, so let's do a sample problem here. So it's on page 699 in your book. So a light bulb draws a current of 0.60 amperes. If the bulb is left on for 8 minutes, how many electrons or elementary charges pass through the bulb? So how many? So how many should spark N? Okay, so when a current exists in a light bulb, it's electrons that are passing through, not protons, so electrons. So if you know the amount of charge that passes through the light bulb, you can use the magnitude of the elementary charge to find the number of electrons. So our goal is to find N. We're trying to find the number of electrons passing through the bulb. So write out what's given. So we have our I, which is our current. We have T, which is our time interval, and we know our elementary charge. Okay? So we're going to use the definition of current to find the amount of charge passing through the light bulb in 8 minutes. So we're going to start with a formula from yesterday. So I equals Q over T, and then we're going to rearrange to solve for Q. Okay, so Q is going to equal current times the time interval. So we're just going to plug that in, make sure you change your times to seconds, and you're going to get 288 coulombs. Okay, so then we're going to take that number and we're going to plug it in Q equals NE. Okay, that formula that we just used. We're going to rearrange to solve for N, right? So Now we have negative 288 coulombs divided by negative 1.60 times 10 to the negative 19 coulombs, right? So N has no unit, right? So this is how many electrons are passing through. So N equals 1.8 times 10 to the negative, or 10 to the 21, sorry. Okay? So that's how we do that problem. And check out page 699 in your book if you want an explanation, like a run through. Okay? So now for today, I'm only going to give you 3 problems. Hopefully an easy Friday for you. So problems 12 to 15 on page 700 in your book. And these are the 3 formulas that you will need to have on your formula sheet for sure, and to be able to use in these questions today. Okay, so again, I will be in the Google Meet from 8:45 to 9:45 today. Send me an email if you don't understand or you have some questions about the material. Other than that, have a great day. Okay.